Hello dear students, in this video I am going to discuss about mechanism of adsorption and factors affecting amount of adsorption. These two topics are from the chapter surface chemistry. Students, from the physical chemistry part, the chapter surface chemistry does not include any numericals. All the theory questions we will get from this chapter, right? Surface chemistry is a branch of chemistry which deals with the study of surfaces and the molecular species which are retained on the surfaces. This is the second part of the surface chemistry, students. Surface chemistry. This is part 2. Part 1 video also I will do it later. When chemical kinetics is completed, later I will start surface chemistry. Part 2. First we should know adsorbent and adsorbate. Adsorbent is the surface on which adsorption takes place. Adsorption takes place is known as adsorbent. Adsorbate. The molecular species which are get adsorbed on the surface of adsorbent, the molecular species which are get adsorbed on the surface of the adsorbent is called as a adsorbate. Students, let us discuss about the mechanism of adsorption. Mechanism of adsorption. For example, we will take a solid particle. The particle it is a solid. The particle in the bulk of the solid, one solid we are considering, it has a force of attraction equally from all the directions. It has force of attraction equally from all the directions. Along the x-axis, y-axis, z-axis, it has a equal force of attraction. But when we consider a particle which is on the surface, it has only inward pull. It has force of attraction only from the downwards. So to balance this, what happens, some gas, when it is coming into contact with the solid, it will absorb that solid, whatever the gas particles they are coming into contact. So that's why adsorption takes place. If we are considering a solid, the particle inside the bulk of the solid, it has a force of attraction equally from all the directions. But the particle on the surface, it has only inward pull. To balance the forces, whatever the substance it is coming into contact with the surface, it will adsorb that. Adsorption is a surface phenomenon. In case of liquids, it is called as a surface tension. In a solid, particle in the bulk as force of attraction equally from all the directions. But a particle on the surface, it has only inward pull. inward pull. To balance this force, it will attract the gaseous molecules, which are coming in contact with the solid. Students, in the bulk of the solid, it has a force of attraction equally from all the directions. But when we consider a particle which is on the surface, it has only inward pull. To balance this inward pull, whatever the gaseous molecules, they are coming into contact with the surface, they will get absorbed by the surface of the solid. So that's why adsorption will occur. Second point in the mechanism of adsorption, let us discuss now. Second point in the mechanism of adsorption. Students, during the adsorption, surface energy of solids decreases. The decrease in surface energy is released in the form of heat. So adsorption is always exothermic process. Students, from the second law of thermodynamics, for a spontaneous process, from the second law of thermodynamics, Gibbs free energy change, that is delta G, should be less than 0, then only process is spontaneous. Delta G is equal to delta H minus T delta S. When a gas is free, gas plus solid, it is giving, when it is get absorbed, it will give us a gas solid, adsorption taking place on the surface of the solid. When it is free, it has entropy is more. When it is get adsorbed on the surface of the solid, entropy is less. So that means delta S for this process, entropy decreases. Entropy earlier it is more, randomness is called as, measure of randomness is called as entropy. When a gas is in the free state, then entropy is more. When it is get adsorbed on the surface of the solid, entropy is less, decreases. Delta S for this process is less than 0. So according to second law of thermodynamics, which says that every spontaneous process will occur in the direction of increasing entropy. So when the delta S is less than 0, then minus T delta S will be, it is greater than 0, because minus into minus we will get it as a plus, greater than 0. So this term is not favorable process, not favorable for this process, adsorption. Then delta H is always, it is less than 0 for the adsorption. And students, delta H, magnitude of delta H should be greater than the T delta S. So higher temperature will not favor this process. Lower temperature is required so that magnitude of delta H is greater than T delta S, then the process will become as a spontaneous. So this is a reason why delta H, that delta H sign always for the adsorption is less than 0. Always the adsorption process is exothermic in nature. Let us discuss about the factors that are affecting adsorption of gases on the solids now. Students, next topic is factors affecting adsorption of gases on solids. Factors affecting adsorption of gases and solids. First factor is nature and surface area of adsorbent. Nature and surface area of adsorbent. Greater the surface area of adsorbent, greater the volume of gases adsorbed. Therefore, silica gel and charcoal are good adsorbents. Students, generally the amount of adsorption the gases are adsorbing on the surface of the solid will depends on the nature as well as the surface area. Greater the surface area of adsorbent, greater the volume of gases adsorbed. Therefore, silica gel and charcoal are good adsorbents. These are adsorbents, means the surface on which adsorption takes place. Nature of adsorbate. Easily liquefiable gases are more soluble in water, are readily adsorbed. So gases which are easily liquefiable, whose critical temperature is greater, higher the critical temperature, then the gas can be easily converted into liquid. Those gases can easily adsorbed on the surface of the solid. Easily liquefiable gases are more soluble in water. Those type of gases are readily adsorbed. For example, if you take N2 gas and ammonia gas, so compared with the N2 gas, NH3 is easily liquefiable gas. So at the similar conditions of temperature and pressure, amount of adsorption in the case of ammonia, it is greater than the amount of adsorption of N2 gas, right? Third factor is temperature. Students, adsorption always exothermic process. Being adsorption always exothermic, increase in temperature will decrease amount of adsorption, which can also be explained with the help of Le-Chatelier principle. So more clearly we will discuss that temperature effect on amount of adsorption by using Le-Chatelier principle now. Students, temperature effect on amount of adsorption more clearly we can explain by using Le-Chatelier principle. Gas is adsorbing on the surface of the solid, which gives gas solid. Adsorption is always exothermic. So amount of heat is released. We can write a Q on the right hand side of the equilibrium equation, right? So according to Le Chatelier's principle, according to Le Chatelier's principle, as the temperature increases, equilibrium will shift in the direction of consuming heat. That is in backward direction. So as the temperature increases, adsorption decreases. Students, according to Le Chatelier's principle, this is in the equilibrium. Gas plus solid gives rise to gas solid plus heat is released. According to Le Chatelier's principle, as the temperature is increases, then what happens? Equilibrium will shift in the direction of consuming heat. Being exothermic process, direction of consuming heat is backward direction. So what is the backward direction? That is decreasing adsorption, amount of adsorption. And fourth factor is pressure. So this is also we can explain with the help of Le Chatelier's principle. Gas solid gives rise to gas solid plus Q. Here heat is not required, amount of heat is not required. So when we try to increase the pressure, then equilibrium will shift in the direction of decreasing pressure. That is, the gas will get adsorbed on the solid, then forward direction it will move. That is, more amount of adsorption will take place. According to Le Chatelier's principle, as the pressure is increased, then equilibrium will shift in the direction of decreasing pressure. That is forward direction. So amount of adsorption increases. Students, that means as the temperature increases, amount of adsorption decreases. As the pressure increases, amount of adsorption increases. These are the factors affecting amount of adsorption. Thank you for watching.